For this lesson, we're looking at when a parallelogram will be a rectangle, rhombus, or square. So what sort of properties must it have to make sure that it's a rectangle, a rhombus, or a square? So for a rectangle, if you have to know it's a parallelogram first. Then, if it has one right angle, then it's a rectangle. You only need to know it has one, because if it has one, then you've got opposite angles are congruent because it's a parallelogram. So if you know one of them, then you know the one that's opposite. And consecutive angles are supplementary. So if this is 90, then its supplement would also be 90. And same thing over there. So you get all four of them. So if you know one is 90 degrees, you know that all four angles are 90 through just a couple of steps. So if one angle is a right angle, then it's a rectangle. The one right angle, that's good enough. If the diagonals are congruent, then the parallelogram is a rectangle also. So if you know the diagonals are congruent and you know opposite sides are parallel, that's good enough also. You can get through and prove that pretty easy just by using some alternate interior angles, proving the triangles are congruent, and going that way. So in order to know a parallelogram is a rectangle, you either need one right angle or congruent diagonals. So given that this is a parallelogram and we're told that the diagonals are congruent, we're going to go through the proof. We talked about it briefly on the last page. Now we're going to go through it in depth. So if the diagonals are congruent, start with ABCD is a parallelogram. So since it's a parallelogram, we know that AB is going to be congruent to CD because those are opposite sides of a parallelogram. So because it is a parallelogram, we know opposite sides are congruent. So AB is congruent to CD. If we wanted to, we could have also said AD is congruent to BC for the same reason. We're also told that we're given, actually, that AC is congruent to BD. The diagonals are congruent. So we can then see, if we look at these two triangles, we can see that they both have BC, so we're going to use that with the reflexive property. And we said that the diagonals were congruent. So now these two triangles, the one I outlined in red and the one I outlined in green, they are congruent by side, side, side. We have all three sides congruent to all three sides. So that's triangle ABC congruent to triangle DCB. Which means that this angle up here at B and this angle down here at C, those are corresponding parts, so they must be congruent. So angle ABC has to be congruent to angle DCB because they are corresponding parts of congruent triangles, CPCTC. But we're told it's a parallelogram, so those angles also are supplementary. because they are consecutive angles. Because AB has to be parallel to DC. Supplementary means they add to 180. Now they're using the other side. Let's change this BAD to ABC. So now by doing some substitution, we have angle, remember that's supposed to say ABC. And we're substituting, instead of DCB, we can substitute in ABC. So we have ABC in there twice. If I would have drawn the triangles the other way, it would have worked with the letters that they have written here. So if 2 times an angle equals 180, that means that that angle equals 90. So it's a right angle. And if we, like I said, if we would have switched that around and drawn the triangles the other way, we could have shown that the other triangles are also right angles. So if they're all right angles, then it must be a rectangle. So we talked about this at the very beginning. We'll go over it one more time. If one angle of a parallelogram is a right angle, then the parallelogram must be a rectangle. Well, if one angle is a right angle, then its opposite angle is also a right angle because opposite angles are congruent. And consecutive angles must be supplementary. So 90 plus 90 equals 180. So we can write opposite angles are congruent. So that means angle G is 90 degrees. Then we use consecutive angles or supplementary. A different color here. So consecutive angles are supplementary. So we do 180 minus 90 means the other angle is 90. So this is 90 and that's 90. So all the angles are right angles, so it's a rectangle. So one of the ways we're going to be using all this is they're going to give you some information and you just have to say whether or not that means it's a rectangle for sure or not. So it's proofs, but it's kind of more of a informal proof. So using the given information, determine if it's a rectangle. So given EF is congruent to GF, and FG is congruent to HE, and FH is congruent to GE. So that's the diagonals. So F, H, and G, E are congruent. That means the diagonals are congruent. And at the very beginning, we said if the diagonals are congruent, then it must be a rectangle. So since the diagonals are congruent, yes, it's a rectangle. We could actually go one step further because we know that these three sides are all congruent. And if it's a rectangle, then opposite sides are congruent, which means all four sides are congruent. So it would actually be a square. But we're getting ahead of ourselves a little bit. So given angle FEG is 45 degrees and angle GEH is 50 degrees. Could it be a rectangle? Well, 50 plus 45 is 95. So no. It has to be 90 degrees, not 95 degrees.